And recording. Awesome. So welcome, I'm Faris. This is Salt Lake City Python Meetup. If you're looking for the PHP Meetup, then you're in the wrong place. We're online, obviously, right now. And we have been for a bit, but we've been on a good cadence. I don't know. We started this meetup almost 8 years ago. I can't believe we're getting closer to the next soiree than the previous one. That's weird to think about. Anyway, we have a soiree in February to celebrate our anniversary. So that's how we kind of keep track of how old we are. But I think we're either getting on 7 or 8 years now. Yeah.
Yeah, it's
Wow.
getting to be a long time. Yeah, we'll have to talk more about the soiree would entail in February.
Yeah,
it's probably bridge when we get there.
Yeah. Well, it'll probably be an online like hackathon thing. We have some ideas on how to make this happen, and we're open to them as well. But anyway, yeah. So Joe piping in was an individual I met at Sugar House Coffee 7 years ago, and serendipitously he had Django running on a machine with a good buddy of mine, Ken Myers. And I was like, we should do a Python group, and we ended up doing a Python group. And 7 years and many venue changes later, we are here on Zoom. It's an interesting venue. Typically, we're at the University of Utah, and we hope to return there fairly soon. Yeah, that's pretty much Salt Lake City Python. We're part of the umbrella organization of Utah Python, which is the nonprofit that helps push Python technology throughout the state. Specifically, other groups include Python Utah North, and specifically we do stuff like, raffle prizes, trying to find speakers and whatnot. And yeah. Sorry, I'm getting like random people messaging me. Okay, awesome. Oh, I know what's going on. Ha 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 ha. A lot of people are joining our Slack and I get a message. Welcome, welcome, welcome. Oh, we have some other stuff. We have swag. So if you want to wear a lovely shirt like this one, you can go here. This is our online shop. All proceeds go directly to our little nonprofit. We have neck gaiters, which are awesome, and face masks. We have these canvas bags. I grabbed one of these just randomly. Hoodies. Yeah. What else do I want to talk about? Oh, other events around Utah tech groups. We have the Salt Lake City Ladies. They're a great group. Feel free to raise your hand on the Zoom chat if you're part of the SLC Ladies or know anybody who is. Should be a little button and you can click raise hand, or you can use the little react in your Zoom control. I'm not sure if we have any Ladies here, but they're a great group. That's a link to theirs. Python at the Point, they're South Valley. Provo, Girl Develop It is not Python oriented. They're more language agnostic and workshop oriented, but also a great group to check out. Language agnostic SLC devs. And we also have SLCPy.com, Python Utah North. These are all sites that you could make pull requests to using our GitHub. So here's our GitHub repos. And again, all this is an Etherpad that anybody can edit and share, and that's linked to our Meetup group. Sponsors are Pythonistas like you, thank you. And Xmission has sponsored our pizza when we were in person, and a number of our raffle prizes. University of Utah has sponsored our venue, and Tech Systems sponsored our latest round of raffle prizes. So new sponsors are always appreciated, and we tend to log things here on SLCPython/money, but I need to go through and like reconcile things because it's getting, whenever it gets more than 2 months behind, it's just me sitting down for an hour and getting this stuff fixed up. So we'll do that. We're tax deductible. As I said, the Utah Python Umbrella Org is a 501c3. So feel free to send us a meetup message if you're interested in any of that tax deduction stuff. And if you or your company is interested in sponsoring us, just send us a message and we'll take it from there. What we like to do, along with introducing everything, is introduce our new members. So if you're new to the meetup, please go through and find the little raise hand icon in Zoom. It might be under more, and raise your hand, and we'll have you introduce yourself to the group. What we try to do is something fun, non-code related. So your name, your occupation, and something you're thankful for. Again, if you're new, feel free to raise your hand. Or has everybody here been here before? Oh, and it looks like we had a few people in the waiting room. Let me turn off the waiting room. I'm sorry about that.
Is reaction disabled? I'm unable to raise my hand.
Oh, you're unable to hit the raise hand. Allow participants. You should be able to raise your hand now. There we go. Rachel raised her hand.
Yeah, hey, yeah, I'm pretty new to Meetup. I've been, kind of watching for events and stuff, but this is the first one I've been to at this group. But I'm in Sandy, Utah right now, and I work for BD as an engineer, and yeah, I'm trying to teach myself coding, so.
Awesome. What's your favorite Thanksgiving dish? Or what's something you're thankful for?
I got a new puppy, so super thankful for that. And favorite Thanksgiving dish, probably mashed potatoes. Classic.
Very good choice. Awesome. Thank you, Rachel. Thanks for introducing yourself. And BD, is that the construction company?
Oh, no, Becton Dickinson. It's a medical device company.
Oh, okay, cool. Awesome. And I see Sue has raised her hand.
Hi. I work for GE Healthcare, and I'm more on the computer vision, CT, X-ray machine stuff. And favorite Thanksgiving dish is scallops potatoes, and I'm thankful for this meetup and being able to learn something new.
Well, we're thankful to have a new member at our meetup, Sue. Awesome. Scallop potatoes. I should try that at Thanksgiving. We always go with the mashed potatoes, but that might be a good spin on it. So I like that. Timothy Johnson, looks like you're new to our group. Go ahead and introduce yourself.
Hi guys, my name is Timothy Johnson, and I'm currently looking for an IT job. We moved to Lehigh from Idaho, but we have been in Utah all our lives. And one thing I'm grateful for is the ability to not hear. I have a device called cochlear implants. I don't know if you can see that, but it's a device that allows me to hear. And when I take them off, I can go better without having to hear. So, sweet dreams.
Well, welcome to the group, Tim. It's nice to have a mute button on life, I guess. But yeah, that's awesome. That's a fun one to be thankful for. I like that take on it. Anybody else would like to raise their hand or introduce yourself? Marcus.
Hey, can you hear me?
I can hear you loud and clear.
Hey, I'm Marcus. I'm a senior engineer for the New York Times. I just moved to Salt Lake City right before the pandemic. I came to one Python meetup, I believe, or it was a data science one. I can't remember, but hello.
Well, hello. Welcome to the team. And you said you work for the New York Times?
Yeah, I'm a senior backend engineer there.
Oh, excellent. Awesome. Welcome to our meetup group. What's something you're thankful for or your favorite Thanksgiving dish?
Oh, I'm thankful for the snow that's going to come this week.
And
Thanksgiving.
Fingers crossed.
Yeah. Probably the orange jello with mandarin oranges. I don't know if anybody else has that, but
I am going to Google that and make it.
Midwest thing, maybe? I don't know. It's pretty good.
Really good. Awesome. Well, welcome to the group, Marcus. Anybody else? Justin Mendoza. Go ahead and introduce yourself.
Can you guys hear me?
Loud and clear.
Cool. Hi, my name is Justin Mendoza. I'm just currently working at Whole Foods. I've been studying SQL Tableau for some time now, and just looking forward to getting to know the industry more, and figured Python would be a pretty good place to start.
Welcome to the group, Justin. Python's an excellent place to start, especially if you're jumping from something like Tableau. You'll find it's a little bit more powerful to play with data once you can actually talk to it in its own language. Justin, what's your favorite? What are you thankful for, or what's your favorite Thanksgiving dish?
Favorite Thanksgiving dish would be a bacon wrapped turkey.
Bacon wrapped turkey. Do you wrap the entire turkey in bacon or just like a leg?
The whole thing.
I need to come over to your house with like a mask on and try that because that sounds delicious. So
It is awesome.
awesome. Well, welcome to the group, Justin.
Thank you.
Ed?
Thank you.
English, it looks like you raised your hand.
Yeah, hey, how you doing? I'm from Florida, so I'm a couple hours ahead of you. I've just recently I've worked with both Tableau and Power BI. I just recently got my Microsoft Power BI certification, data analyst, and I'm at the point where I need to start incorporating Python into Power BI. And here's where I'm starting.
It's a great place to start in my very biased opinion. Ed, do you have anything you're thankful for or a favorite Thanksgiving dish?
I'm thankful for our election going on right now, and my pecan pie would have to be my favorite.
Pecan pie and democracy. Is there anything more American?
Yeah, there you go.
Like it, Ed. I like it. Liz, welcome to the group. Looks like you raised your hand.
Yes, hello everyone. Good to meet you all. This is my first time attending this group for this event. I am actually currently a student. I'm gonna look out for a job. I'm major in business information, business intelligence. So I'm currently working doing forecasting in R. So, and I look forward and I'm excited what I learn in here for this meetup, for this meeting. So, yeah.
What's something you're thankful for? Or do you have a favorite Thanksgiving dish?
I like turkey.
Turkey.
But what I'm thankful for is I'm thankful that I am healthy.
That's a really good one. I think that's going to be top of everybody's list this year. Good call. Can I ask where you're a student right now, Liz? Where are you studying?
I am studying at UVU and I'm graduating on May.
Oh, congrats. Awesome.
So I have 1 semester left.
Excellent. Well, welcome to the Meetup group. Hopefully we can either convince you away from R or maybe even make your R coding a little bit better. I find that knowing more than one language definitely helps the other languages. So anybody else who'd like to introduce themselves?
It is.
Yeah, definitely. Ollie? Looks like Ollie raised his hand, or her. Sorry if I...
Can you hear me?
Yeah.
Yeah, my name's Oli. I'm a business intelligence engineer at a company called Health Equity. It's good to be here. Thanks.
And anything you're thankful for? Or do you got a good dish that you're favorite?
Favorite Thanksgiving dish. My family does this caramelized potatoes that I really like. They're good.
That sounds amazing.
Mm-hmm. And they're hard to make, but they're real good. And I'm thankful for the new, I just moved and I live on a new street and it has a bunch of trees and I love it. So I'm really thankful for that.
And is that in Utah? We've had a lot of out-of-staters lately, so.
Oh, yeah, in Utah.
Awesome. Well, welcome to Utah. Well, I don't know if you moved from Utah to Utah.
From Utah.
Oh, okay.
To Utah.
Well, welcome to your new street with trees, apparently.
Thank you.
Awesome. Anybody else like to introduce themselves? All right, going once, going twice. Okay, we'll move on to the next point on our agenda. As you know, PyCon has been canceled. So we always talk about who's hiring. So as you know, PyCon's been canceled. So here's a link to the job fair that they held online. They're still doing some updates, not as many. I didn't see one in the last couple of weeks, but they have been updating this page a little bit. Python Jobs HQ is far more updated. It's a great online resource for people looking for Python-oriented jobs. Tech systems, it looks like we got Kate Conroe online. Do you want me to give the spiel or do you want to give the spiel?
I was able to make it tonight. Yay. Sorry, I was a little bit late though. Hi, Hi guys. Hey Dylan. So yeah, hi guys. For those that I haven't had a chance to meet yet, and girls, I shouldn't just say guys. I'm Kate. I'm with Tech Systems. We've been sponsoring the Python Meetup group for a while. Super excited to be a part of this group. I personally tell people constantly how amazing this group is. I sponsor a few different meetup groups, but I personally think this is the most fun one in Utah. Don't tell anyone I said that, but because I don't want to make anyone jealous, but this is seriously like the best group. I love you guys. So yeah, I mean, we get some really good Python roles from time to time. COVID kind of shook the world up. We're recruiting in different ways now. So a lot of what I've been doing for people lately is trying to find remote roles internationally. So that means that a lot of the recruiting I do is people coming to me with like, hey, I need a job. And I'm like, cool, let me hop in my system and see what I've got that's remote. So actually, like while I was sitting here talking, I was like, I'm going to just type in Python in my system and click, for 100% remote roles and see how many positions I come up with. So let's see. 239 roles in my system right now that have the word Python and are 100% remote. So it's really opened up kind of the pool of what we can do for people with COVID. I will say if COVID did anything positive, there we go. It allowed a lot of people to have more diversity in the roles that they can look at and to work from our homes, which is kind of cool. Like I love sitting here in my little nook with my dogs. So anytime you need anything, feel free to reach out.
And I will add to that and say that Tech Systems generally, I'm a little bit biased. They got me my first really good career in Utah, like 8 years ago. But what I liked about them versus other recruiters, because recruiters can definitely be annoying, which is a good problem. But what I like is that recruiters from Tech System, they know who they're talking to. They have an idea of the skills that you want to actually use. And I was never asked to do like an iOS app, right? So if you know of like, if you've ever worked with recruiters, they tend to not know what you're good at, and you'll be asked to work on something PHP or some like Java Android thing that's used to spy on people. You don't want that. Go with Tech Systems. They'll make sure that you two are aligned, and if you're not aligned, they'll tell you. So I really like to work with you guys. So
thanks, Faris.
Yeah, of course. So Invite is also hiring. That's where I work. Feel free to send me a message. They're specifically looking for data engineering roles and senior full stack with a Python focus and React. Recursion Pharmaceuticals, is anybody from there online right now? Feel free to raise your hand or just speak up. If not, I will remove this. Come on, screen twice. Okay, well, I'm removing it because there's nobody here to speak for it. However, it remains in the history of this Etherpad and also in the October agenda. But they were hiring. I cannot confirm if they are anymore. Looks like somebody added test ramp, or was this here before?
No, I added that.
Would you like to speak more about it?
Of course. Yeah, so test ramp, they're a client of mine. And they're looking for somebody who is probably more fluent in Node, but I think Python is part of that. So just somebody who's good at backend engineering skills. You'll probably be expected to learn Snowflake, which is why I'm working with them. So I think they do like software testing as a service or something like that. So, so if that interests you, test round, one call, that's all. Thanks.
Awesome. Thanks for that lead. Oh, it looks like we got more coming in. Verdigris?
Dylan needs a friend. That's why he's putting in there.
Oh.
Dylan needs a friend.
Oh, okay.
Yeah. All right. I'll give a little pitch about Verdigris. So we're working to sustain human life by making buildings more energy efficient. So trying to reduce energy footprint. We have an IoT device that measures electricity, and then AI on top of that. AI to do forecasting and predictions on those. We're looking for a machine learning engineer to help out with productionizing models and work with me. So
yeah, and if you pass the pop quiz, you pass the pop quiz that Dylan will give at the end of his talk, then you got a job at Verdigris. That's what he told me. Like, no take back fees. No, I'm just kidding. But this is very much in line with what Dylan does day to day. So I'm actually looking really forward to this talk. It's going to be awesome. Anyone else know of anyone hiring? Going once, going twice. Okay. Anyone looking? And now's your chance to definitely get on the Etherpad if you are somebody who's looking. Also, please raise your hand in the participant view again, and I can call on you, and we can type stuff in together, and you can market yourself and introduce yourself. Timothy Johnson. Look at that. For anybody who's trying to recruit Nightrat, look at that initiative. Can I just say, like, and this is being recorded, Tim, so feel free to like bookmark this part and like just play it back and to potential interviewers. Do you want to tell us more about yourself before I keep rambling?
So before we continue, I'm Hardiffian, so I want to clarify. You want us to say we're looking for something, right? Rather than people hiring it.
Yes.
We're looking to hire, right?
Yes, this is the yin to the yin. This is the other side of it. Yes. Okay,
so basically representing ourselves so that we may get hired, right?
Yeah. Market yourself.
Oh, okay. Okay, cool. All right, so I have been programming for like 7+ years now. I started like way back in like child tabulator or something. My dad got me into programming, and he saw that I had interest because I was doing something called redstone engineering in Minecraft, trying to put together to figure out the logic. He saw that in me, and he saw that I have the capacity to connect the pieces together to make something work. And then, so I learned about Java to start off. Then in Java, it was hard. It was a little bit trickier. But so then I switched over to Python. It was the best decision ever. I love Python. It's like so nice. It's so useful. So I have been doing lots of Python projects, lots of it, just like to try an idea out to see if it works or it doesn't work, just to mess around. And then
anything specifically you're looking to work on, web or data?
Right. Okay. I am specific. Well, now I am, because I'm doing college, right? So what I'm doing is I'm applying what I learned in college, right? So I learned up on MySQL, and then I learned how do I apply that in my life? How do I take something that's, one side and convert it into something useful in personal life so that I can learn how to use it more, And one of the projects I integrates Python, MySQL, Linux, and HTML as well. All of them together as 2 projects. One of them was to work on the college tracker. It actually worked out really well for me, and I'm really happy about it. It's mostly from terminal line, but hey, that's easy to do. You have to translate that into HTML and you're good to go, right? But I'm a CLI guy, I do it from the command line, so I kind of stuck with her. And then the other one is to, I can't quite remember.
No worries.
Yeah, cool notes. Sorry, cool notes. This one's actually really cool.
No worries. How about add your contact details in here, and then make sure that you add anything that I missed in here. But yeah, it sounds like it sounds like you're a student looking for your first real role in Python. So that's awesome.
What school are you going to, Timothy?
I am going to BYU Idaho online. It's an online schooling.
Cool.
And the resources has been proven useful. They use external links to like Codecademy, Cisco routing website, like the actual website, like they cover all the cultures for that. So you can actually dive in and learn from the world and not from textbooks, It's like a plain education, so it's really cool.
Awesome.
Cool. A very good friend of mine is a professor in the software engineering department over there. His name is Sean Murdoch. Have you met him?
I heard him. Yeah. I think I'm in his Slack group right now. He's a great teacher.
That's awesome. Fawn is very, very smart. I've been able to place him in several really good software engineering roles. He really knows his stuff, so pay attention.
I will.
Small world. Like it. Well, Tim, and then feel free to add your contact details right in the agenda. And we'll move on to Rachel so that we're cognizant of time right now. Rachel, welcome.
Hey, thanks. So my situation is I'm not looking right now. I'm actually, backstory, I'm in this rotational program and, my background's mechanical engineering. So I got into this rotational program thinking I wanted to do mechanical engineering. And then I started taking some online courses and, I'd already done some coding in the past in school here and there, like with MATLAB. But then I just started getting really interested in it, taking courses online and stuff. And then made a web app for work and decided I definitely want to pursue software instead. So right now I'm in a rotation. I'm actually doing some software and it's remote, but out of San Diego. So I rotate in July. So basically I have to, around March, I'll figure out if I'm gonna take another rotation somewhere else that is doing software, but those options are really limited. So I'm not really sure I'm gonna be doing that. So I'll probably be looking around that time. And I was actually curious what you guys, or what the timeline goes as far as when people start looking for jobs versus when they can start. Because in college, because I'm only 2 years out, not even 2 years out of college, and back then I found my job in November and had it set up for May. So I'm wondering how early you can kind of start interviewing, or how early I should start interviewing before I plan on starting a new job in June or July.
That's a good question. Coming from student onto your first job is much different than job to job. So I'll open with that. And then it's a lot different experience. Mm-hmm. So based on my personal experience, I found what you're doing right now is probably the best track. So if I understand correctly, you're in school, but you're currently working with an org in San Diego.
No, I'm actually, I graduated not this past May, but the May before, May of 2019.
Okay.
So yeah, so I'm out of college and now in a rotational program, engineering rotational program.
Oh, I see. Yeah. So hopping onto a new role like that, I mean, if I was in your shoes, part of what I would do is market myself as hey, I'm cross-disciplinary. Recruiters love that stuff on their resume. Oh, Kate, could you mute everything I'm saying right now so that you don't know all the tricks that I use? So yeah, so recruiters love seeing interdisciplinary. Make it a point, I would also say, especially if you're crossing disciplines, cover letters do not become optional at that point, right? If you're hopping to a new job and it's not in the role that you studied for, or not in the role that you've maybe worked deep into, then add a cover letter, and in that cover letter you should promote yourself as being somebody who's dynamic and flexible, and look at me, I'm able to hop disciplines. Yeah. Anybody else have something to add? Any advice? Joe?
Yeah. Oh, yeah. Hi. The advice I give is definitely build your network now as you're doing. And the best employment opportunities also I found tend to come from jobs that may not even be listed. You may meet some people that have an opportunity and they'd be willing to take a chance on you, especially when you're new, and especially in a market like this, it might be competitive. You really have to prove yourself. So if you can sort of circumvent maybe the traditional gatekeepers and find your way to success other ways, I think that's perfectly valid. So
yeah, to touch on that, the last job I had before this one, I did not go through the normal process. I just knew people, and that helps a ton. When you just know somebody, you get to skip steps, which is really nice. Yeah, awesome.
I wanted to add too, because you specifically.
you should also make friends with people like Kate. She knows a lot of companies that are hiring, so that's also a good idea. So.
Cool.
Well, one thing that you might want to do, because you asked about timelines, is that really big companies are often much more flexible about when your start date can be. So what your strategy you might want to consider is, while you're networking and all that other stuff, apply to big companies that you might want to work at, or maybe ones that you don't want to work at. And then you can use that as sort of experience interviewing. And then worst case scenario, nothing comes of that, but you're better at interviewing. But best case scenario is that maybe you say, oh, well, you know, I'm going to graduate in May. And they're like, okay, well, let us know by May. That happened to me when I was about to graduate. I applied to Cerner, which is like second to Epic in the EMR world. Yeah. And they held my basically an open spot for me for like 3 months while I interviewed at other places. I ended up not going to them, but that was fine with them. So big companies like that give you a lot of flexibility in a lot of cases. So I don't know what it's like in COVID times, but that might be a strategy that you employ, because you could start interviewing even now, start applying for those things. Then as you get closer to that graduation date, then start applying to maybe smaller companies or other ones that might look more appealing to you.
Yeah. Okay. Yeah. That's good advice. Well, thanks, appreciate it. That's all really good advice. So it's a good idea.
Well, and welcome to the group.
Thanks. Yeah, excited to be here.
Anybody else? Feel free to raise your hand if you are looking. Justin, go for it.
With all the data knowledge I've been obtaining through Coursera courses, through SQL, joins, inner, outer, sub-queries, and then at the very end being told you only want to use as many joins as possible, because it reduces increases the time to basically run what kind of query you want. Just trying to you just want to keep it as simple as possible. Working with databases, SQL Server 2019, MAMP, PHP, MySQL, learning the different dialects, and just trying to find something with like database modeling in that kind of direction, as well as I mentioned before, I have some experience with Tableau, and it is a really nice tool. And the one thing, especially the calculated stuff you can do with it, you can manipulate the data to whatever you need. And the forecasting part is also pretty nice. But this is the direction I'm trying to go into.
Awesome. So if I understand correctly, you're looking at kind of more of an introductory DB role, something kind of get you ramped up and professional for database stuff.
Correct.
Awesome. And yeah, add more details here. I'm making like one-word summaries of your sentences as you're talking, but definitely add your contact details in here. And then yeah, anybody who's looking, this is a great place. Awesome. Anybody else? Feel free to raise your hand. And thanks, Justin.
Thank you.
Going once, going twice. All right. Community news. I mentioned that these talks are up, Python 2020. Oh, speaking of Tableau, so my partner, she works in a lot of Tableau. Did anybody go to Tableau Conf online or even catch it from somebody? Like anybody at all? I gotta say, they did really well jumping to online format. It was a really well put together production. What did they have specifically? Oh, they had like how do you say, runners, or you know those ads that run on TV sometimes, but they're not actually ads. But they just had all these parodies in between where, I don't know, one of them was really funny. It was like a couple parents looking down in a crib and, oh, they're going to say his first words. And the first word's data. And it's just a little Tableau app in the crib. And it was really funny. So I don't know. They did a good job this year, kind of rolled with the punches. So I gotta give a hats off to that conference. Release candidate for 3.9. Sorry, back to community news. We can play with it. I had some links in here. I was going to play with this maybe this meetup, but we're running short on time, and I want to make sure that Dylan has enough time to predict the future.
You're okay, Faris.
Okay. And I don't have this ready. That's the other thing. And anytime I run Docker while I'm doing a Zoom share, things just are not nice.
Isn't 3.9 like public general availability now?
At the time, it was RC. Maybe it went to. Okay.
I remember I downloaded it. So unless I'm forgetful, which is totally possible.
3.9 is released. 3.10 is now in alpha.
Yeah, I'm not totally going insane.
Released today, so that's why I'm okay. That's I think it's fair that I thought it was still in RC.
Yeah,
it was released
totally
today.
Fine. Yeah. Okay, cool.
Okay.
Man, I need to work with Joe. He literally works with cutting edge technology. So.
But yeah.
Oh, you know what? Never mind. Released on October 5th.
Yeah, I was gonna say.
Okay.
Yeah.
This is okay. Never mind.
It doesn't really add that much, I would say. It has some pretty cool stuff with like dictionaries, but I don't know.
This I already played with way too much. Because
that's a cool feature, but yeah, the rest of it is they're tweaking some things and some under the hood stuff that doesn't.
This is the old way to do it, and then I think you can just use. What's the new one? Is it .union now? Oh no, they added an operator.
Pipe, yeah.
It's pipe equal. Yeah. Fun. Yeah, lots of syntactic sugar lately in the releases, hey? Sweet. Utah Python. Oh, right. So we got swag for our Utah Python logo. I don't know why it said we can't find that, but that's okay. I will fix that link later. But yeah, I already mentioned the Teespring. Feel free to ping me if you're looking for swag. And we do have a Utah Python logo that has its own repo, so you can. Oh, and it is approved by the Python Software Foundation. Thanks to Dylan. He went through all that bureaucratic fun to make sure that we are good to go. So we're not violating any intellectual property laws with our little modification. And in fact, they give it the stamp of approval. So that's kind of cool. Data Heretics is this is a podcast, right? That Joe, you're running. Do you want to introduce this a little?
Yeah, I run a few podcasts actually. Data Heretics is a group of myself and 3 other data scientists kind of spread all over the world. We're going to have our next live stream, I think end of month now. So stay tuned for that. Last time we had like 600 people who are crazy enough to want to listen to me and 3 other people talk for 2 hours. So if you want to learn about data and all the things you can do wrong with it, then just show up. It'll be great. So, and we have another event this Friday. Has anyone heard of Prefect? Has anyone heard of Airflow?
I have both.
Dylan raising two arms. So we got Mary Claire Thompson. She's a data engineer from Duke University. She's going to be talking about how they use Prefect. So I think that's going to be pretty cool. Prefect came about to address some of the shortcomings of Airflow. So stay tuned for that. Message me for information. I didn't do the best job at promoting this event. But just hit me up in the chat here if you want to join that. It's Friday at noon. So.
Thanks, Joe. Sorry, I was trying to add it, but I
Don't
lost
worry
my
about it.
cursor. There it goes. Okay. Come on. Hit enter. There we go. No?
I could also do this. Don't worry about it. I'll do it.
Okay.
Yeah.
It's hard because I think Zoom keeps stealing my focus. Yeah, that's what's going on. Yep. Okay. Anyway. All right. Any other community news happening? I don't think there's anything significant in the world happening at all today. So there's no news at all. So awesome. That sounds good. Dylan, are you ready to take it away? Or do you need me to like stall a little bit and do like a dance?
I'm ready to take it away.
Awesome. I'm going to stop my screen share and let you take it.
All right. How's everyone doing? Let's see here.
And just FYI, this is also my dinner time, so that's why I mute my video.
Sounds good. I think Faris is going to be watching the chat and just speak up if you have any questions as I go through my presentation. And we'll have a good little discussion about forecasting. All right. Slides. Present. Loading. All right. Hey everyone, so this is my talk, the Python Crystal Ball, using machine learning to predict the future. A little bit about me, I'm Dylan Gregersen. I'm one of the co-organizers of this here meetup. I work as a senior data scientist at Verdigris, which I mentioned earlier. We do building energy optimization to help fight climate change and sustain human life on Earth. Cool. All right, so the first thing to get across is, right, predicting the future is hard. As we are like currently in the midst, 2020 has shown us that it's very hard to predict like whatever the outcome will be. And so even once we go through and try to come up with some sort of model or some sort of representation of the world, whether it's in our head or mathematically, things will come at us sideways and we won't be able to understand. So there's some key elements to that when we go to take essentially what's in our heads of how we predict and try to make mathematical models that will help to predict into the future. Oh, and on this, predicting is hard. So last like Friday, I think it was, we were looking for a speaker and I predicted that I'd totally be able to make this presentation as good as I wanted to. And predicting the future is hard. So there's been craziness with the world. I also put in an offer on a house yesterday and things are going like, it's a lot. So my presentation, I have like the content, but we're gonna be going through this. There's gonna be a lot more live code than slides. Hopefully you appreciate that.
I have to add one thing before Dylan keeps going, because Dylan and I are good buddies. And Dylan's given more talks at this meetup than probably everybody else. And back in March, Dylan gave another talk about data, and it had to do with the specific data set, and it was the COVID data set.
Yeah.
So about a week ago, and this is in the description, the joke was, well, if you're going to do a time series presentation, please don't do COVID.
Yep.
So of course, what does Dylan do, right? Like, look, there's a little screenshot of the election. So this is just like a note to just, if you're going to work with Dylan, this is what you're going to get. But it's going to be quality. But
though I will say, Faris, I did giggle to myself about it. But in the end, I did not do the election, and I also did not do civil unrest. Thank
you, Dylan.
So it's not as bad as the forecasting talk I gave a few years ago, where I predicted the price of Bitcoin when it was at its very peak.
Oh yeah. Yeah, I remember you doing that one. That was a good one.
That video is online, so I'm wondering if we could find screenshots of that, and just be like, see how wrong we were. Anyway, I'll stop interrupting. Yeah. Sorry about that.
I'll hold you in suspense for what I actually chose.
Okay, awesome.
So in time series forecasting, there's a general formulation used in time series forecasting as well as machine learning in general. We have kind of these seven steps. Some people might break them up or move them around a little bit. But first we have to load our data in. We then prepare it and create features about our data. We then select a model. We do a training for the model where the model representation has some internal parameters. And by giving it data, those internal parameters are adjusted until we find a good match for the data. And so then that's the training process. There's an evaluation process to make sure that your training is not, that your training is good. There's a tuning step where you take the model and it usually has some of its own parameters that you can tweak. And so you tweak those parameters and do different trainings. You can try out different models. This is where we kind of iterate and figure out what is a good representation for our forecasting. And then prediction, where we're actually taking this model, doing prediction, and putting it in production. One of the things I wanted to do with this talk is to spend a little bit of time on the actual modeling, and how like each of these steps plays out. But one of the things that I've seen a lot of, and that is very different in a real world application. So I've seen a lot of talks where somebody has a Jupyter notebook. This is a way to execute Python. And they go through the Jupyter notebook and it has all of the things in it. And then at the end, they're like, here was time series forecasting. But in the real world, using a notebook as your final, like, this is my end product, this is my code, is a poor practice. Notebooks are not a great, and this is maybe controversial. If you want to raise some controversy, I'll bite you. But notebooks do not promote the best coding practices. They don't, it's not the best development environment. So when you're developing, there's lots of tools in editors like VS Code or PyCharm that help you fix bugs early and check, test your code and help you with the steps of development. And notebooks really don't have those built in. I think they'll eventually keep adding those features, but I don't think there's really, like, the notebook is not a substitute for creating the Python code itself. And so I wanted to, in this talk, not just show you time series forecasting, but show you kind of my, how I structure a project so that it would be going from 0 all the way to something that I would put in production. All right, I wanted to touch on this a little bit. So components of time series forecasting, just the model itself. There's typically a few different pieces that go into it. So this graph right here in the middle shows time series forecasting the stock price of Walmart stock over time. The model that's being fit is actually Facebook's profit model, which I have also used, but it has all of these different pieces and it allows you to kind of piece those apart. So your seasonal trends, your weekly trends, and your yearly trends. And what happens is each of these different pieces gets added together to produce this final model. So every week there's like little dips throughout the week, and that gets added on top of your overall trend, which gets added on top of the seasonality, up and down, up and down. So all of these different components go into creating a model that that can reflect how the data is behaving. And I'll talk a little bit more about Facebook profit, but you can see a few nice things in here. It can handle discrete changes. So when there's a change point, it essentially says, like, between here and here is linear growth, between here and here. It adjusts where the trends are. It adds in the seasonality. It adds in the weekly trends. So if we look really closely, there's little bumps. Probably can't see it. And then it also gives you, its output also gives you confidence intervals for the forecast, which is pretty nice. All right. So I'm going to jump into some live code and kind of walk through what these different steps are. If you have any questions throughout this, just stop me and be like, hey, what's that? Hey, like, how do you, I don't know, import, how do you set up different pieces or do the code? I want to kind of explore also how I'm doing it, not just what I'm doing in the modeling. Everybody good? Everyone give a nod to that? Yeah, okay, cool. Let's see here, live code. Just minimize that. All right, so here on the left, well, I guess I'll start first. Here's my, here's the code and the project structure. I'm using VS Code as an editor. And this is the code that I pushed up to GitHub. It's available if you want to look at it, try it out. I started out by building this off of a cookie cutter. It's just a way that just kind of, it's a tool that's been developed that creates essentially a template for how the whole project should be structured. But then I've made a few changes. So you can see here, these are the requirements, the Python requirements for everything that I'm going to be importing. I created a separate requirements for things when I'm developing that would be different from when I might put my code into production. So for example, when I put my code into production, I actually don't need Jupyter Lab or notebooks. I only need the actual pieces that are going to be grabbing the code, getting data, and analyzing that data. So I have these two different files, and then I'm using a tool called Docker. And what Docker is doing here is it's building off of a base Jupyter image, and then it's setting up my requirements. So here is those requirements from the requirements.txt. It copies over some source code that would be used in production. Then I'm using staged builds. So this is a way to create, instead of, it's all in one file, but instead of having my release build, I might have just the staged build. And so in the staged build, I'm adding in the requirements here, and I will start up this runtime environment, which is what Docker provides you. It essentially provides you a way to execute code with all of its dependencies, everything that it needs to run. It executes that code as one environment. And so this will start up my Jupyter notebook, which is running, not this guy, over here currently. And one final note on Docker, I'm using Docker Compose, which is essentially a way to write parameters for running the Docker container. So when I want to actually start this, I'm using Docker Compose dev, and it starts my notebook so that I can access it over here. Crash course on Docker. Any questions? I could spend maybe 5-7 minutes on this if people have a few questions about Docker.
I have a question.
Okay.
So I have done a little research about it, but I haven't gone into depth about it. So is Docker mainly used to modularize and or to deploy code, and like, what's its purpose really?
Yes, that you're right. It's meant to modularize and be able to deploy code. In some ways, I think about it as an executable. So in the Windows realm, executables are all of the binary code to run your program. And in Docker's world, you create an image, and that image has all of the binaries. So there's multiple binaries in this sense, but essentially contains everything you need to run the code. And it stores that as an image, so the kind of equivalent to an executable. And then any other place system that has Docker can take that image and run it and run that code as a container.
That way, if you have like something that's specifically to Windows, can be run on Mac, basically.
Yes.
Like a.
Yep. So it allows that sort of portability. That's a buzzword around this, is being able to take the image and move it around to different operating systems, hand it off and run it on different hardware. And so you have essentially an artifact, a thing that you can hand off to somebody, a set of bytes that you can hand to somebody that they can run.
Okay, thank you.
You're welcome.
With your YAML file, I've always used Docker Compose up or Docker Compose down or something. Instead, do you have to do like Docker Compose dev up, or with like services you can just define it as dev or release, and release would be like a prod environment, and then dev is like when you're running it locally? Gotcha.
Yeah, so you are definitely right. So Docker, I'll clear this. Let's see if I can make a little, code's a little bigger. All right, that's probably a good thing. So I'm using Docker Compose, which uses this YAML file. Each of the services can be accessed via its name. And then Docker Compose has some commands. So these are the different commands. The one you referred to, which is correct, is Docker Compose up, which will create the images if they're not created and to run them. And you can specify after that a specific service if you want to run just that service.
Gotcha, thanks, that clears it up.
All right, got a few more minutes on my little 5-minute timer. If there's maybe one more question on that. We'll move on past Docker after this. All right. Thanks for your questions. All right, so Docker is now running my Jupyter notebook. There's a command called PS that shows me what is currently running. And so you can see my release container here, it has exited, and my development container is up and running. I'm forwarding a port, and so I can access that over in a browser by going to that port, and then it adds in these extra pieces. I won't close that tab, but essentially opening this up, and it runs the notebooks, specifically running Jupyter Lab, which is a version of Jupyter Notebooks.
So the ports argument with the colon, that just means forward my local 83 to 88?
Correct.
Okay, gotcha.
Yep. That's really useful. So yeah, what he's saying is the port on my host machine, forward it to 88, which is what Jupyter is doing. And so these ports are really how the machines talk to each other. And I run lots of these notebooks. I have usually lots of different containers. And so that's why I do some extra mapping, because 88 is actually being used by another container. So I can have multiple containers running on the same machine. And Timothy, this adds to yours a little bit. Another reason to use Docker is for portability. You can have very different environments all running on the same machine. So if I want different versions of Python, different libraries, different C files that those libraries use, I can have all of those, but have them be separate.
Do you experience much of a performance hit doing that by containerizing all of this for your workflows?
There's a little bit of performance hit because there's an overhead with running it as a container, which is Docker uses a lightweight virtual machine to run it. So far I've been fine with it, Matt. It's I will say, so when you download Docker, there is a set of preferences that's going to open up, but I give Docker almost like 90% access to 90% of the resources. So increase the memory, I give it all of the CPUs, and usually turn down the swap. So like these resources that Docker can access for my computer, I set those up that way.
Yeah, that makes sense. I was using Docker at one point for a bunch of Postgres installs, but we were getting issues with I/O. But for your workflow, that probably isn't quite as as important as running a full-scale relational database and virtualizing that, you know, the I guess the non-ephemeral connection to the storage space.
Yeah, yeah. So you were running it as the Postgres as its own container. That was the problem.
We tried to get some like load balancing stuff set up, and it was just like the performance is just so bad compared to bare metal. I mean, this is a couple of years ago, so it's probably better at this point.
Yeah, well, and one of the things that Docker allows, to your point, is if I wanted to have another service here that was my database, and let's say I use an image that's available called Postgres, I might do this during development environments, maybe even a stage environment, but then create, you know, a bare metal actual Postgres instance in production. I wouldn't use Docker at that sense. But what Docker does help you do is it essentially treats each of these services on a network. And so it already kind of forces you into developing in a way that has to use a network. And so you can easily separate out services and actually put them in different places, or even totally change out how that service is running, like changing it from a Postgres Docker container to an actual Postgres server.
So does that mean you can do both at the same time? Like you can have development and in development, basically, as well as in release?
Yep. So like if I have I can redirect my port, so you can have both.
So yeah, the cool. Release or just a name that you give it to each group. So that means you can have custom name, right?
Yeah, I could have this. This could be any name. and then it would be accessed via that name. And this is actually just for Docker Compose. The Docker cares more about the image and the container name than this name. And so that's kind of where that falls out. But let's move on to the notebook itself. So in my notebook, I said I was going to kind of go over these different steps in my development environment where I have code on one side. So I actually have this repository that has different code, the actual code that I'd be running, and then my notebook. And in the notebook is really nice for exploration, for iterative development, for kind of rapid prototyping. But like I said, it's not great for final code production. And so here I'm importing a basic thing about notebooks, a notebook is a mixture of markdown text and Python execution cells. So this actually executes Python. If I do print hello world, it'll print out hello world. So this is executing Python code. And when in the development environment, one of the things I've been using recently is this little magic piece where it will reload my library every time I make a change. I'll demonstrate this in a minute, but this makes it much easier to be working in the notebook and in my code base at the same time. So our first step, right, is to load data in. And here I have some parameters for loading the data. And I have a start time and an end time. And then I have keywords. So what data I ended up using is Wikipedia articles. So if you go to a Wikipedia article, there is an API that allows you to access how many views it's had over time. So instead of, I looked at some election things, and I looked at like some different like civil rights things, and then I ended up going with gardening, because that's a current hobby that I've been like exploring a lot. So we have gardening. I have a few different articles here. So if I go over here, I can actually go to this article about what regenerative agriculture is. But for the purpose of this talk, what I really care about is as a time series. And so I have these parameters, and then I have a function here that actually loads the data. So where that's coming from is inside Crystal Ball, inside load data. There's a bunch of these functions. And one of the functions that I have is get Wikipedia daily view count. And this takes an article name and start and stop parameters, and then it calls the API right here and returns to me a table of data that I can use. So if I come back over here, I can actually look at this table of data, and we can see that I have several columns. I have a project column, I have an article, a granularity, a time step, an access, an agent, and a view, and the view count. So one of the things that's good to do from this production idea, while I'm also developing, is to create functions that will check my data for me. And so this is like I could put a step in that will actually say, hey, when I grab the data, make sure it has the right columns, make sure those columns have the right values in them, and have some expectations that you check. So I'm checking here if I'm missing any columns. I'm checking here if there's any negative values in views, because that would be bad. I don't expect there to be negative values. And if there is, that indicates that something's wrong in my pipeline. And one of the things that the whole industry of data science is moving towards is being able to have these sorts of tests, because data itself traditionally has not had any sort of validation or tests on it. So one of the steps I'd recommend adding in is this validation of the data, and it runs this function and checks my input data. And then I have a function here that will actually visualize the data. And so if I wanted to, what I could do now with these functions is compile them into a step that would load data, store it somewhere, visualize it for me, and then I could just look at those visualizations without having to be in the notebook or execute code. I can have something else execute the code. So this is really where the power of having everything in functions comes in, because I can write regular Python code now. I could add tests in, I can add scripts in, and this is sort of the in-between where I can do it interactively. If I wanted to look at something else rapidly, I could say, okay, hey, what's, if I do a group by article and I want to do views and I want to look at the mean view count, I could do some of these explorations, and I could even add in, so on this plot, I could be like, oh, well, what I need to do really quick is have my mean data. And so this is my like, and then I could say for article and mean in mean data items, I need my figure. So this will give me the actual plot object. So I'm saying, okay, give me a plot, put this, all of this stuff on the plot. Now I want to look at a few other things. I want to look at a horizontal line at the mean, and I want to add a label called article. Ooh. So this is where we get to something exciting. So the mean is a lot higher than my data. My data, if I say, okay, let's actually remove this. This is the interactability between the notebook and the code. Oh, these are really small values. What did I actually do here? Well, I actually did, so under crystal ball visualization and plot articles, Oh, I actually did it as a rolling mean on a percentage. Okay. That's not great. So I'm not going to actually comment that line out and save it. And now because of that little import thing I did at the top, it will automatically reload the module for me. And so if I rerun this, now we're back to the straight view counts for each of these articles. You're welcome to applaud at this point. Thanks, Faris. Thanks, Joe. Or Faris. Joe, you need to applaud. Come on. Now I can add that mean back in for the exploration. I can see the mean value on each of these. If I wanted to, if this is something I wanted to see ongoing, I can take that and add it in over here and say, hey, this is the article. You know, I now really like this thing. I'm gonna just take the mean of it. And I'm gonna actually choose the color as that same color. I save it. This will automatically reload it.
Do you have to,
Go ahead.
rerun the cell once you've saved in your VS Code?
Yes.
Okay, gotcha.
Yep.
It just reloads every like background stuff like your visualization module.
Yep.
Okay.
I'm hoping it does something fancy where it actually checks the cache and sees if anything changed instead of reloading everything. I imagine it does. I haven't looked at the guts of it, but what I do know is that, yeah, when you run the cell, it checks if any modules have been updated and re-imports them.
Can I ask you a question about this?
Mm-hmm.
Thank you. I think that you're using pandas to create all of these features. Is that right?
Correct.
Okay. I've been working on a project just like yours, very similar, but I have like hundreds of millions of rows and it's like hundreds of gigabytes of data. And I'm using pandas like you. And I noticed that when I use pandas to create these features, the machine is using only one core and out of 128 cores, and 127 cores are sitting there unused. So pandas does not run in parallel. So it's taking like many hours to create all of my features. I was wondering, is that right? Pandas is not parallel, and should I maybe switch to Dask instead?
Yeah,
it would.
Yeah, pandas is not parallelized well. There's actually there's a pretty good article by the maker of pandas where he goes through and is like, these are all the terrible things I did when I made this. Dask would help with this, or consider also using PySpark. Okay. PySpark has a distributed data frame that behaves very similar to pandas, but it actually stores your data on a cluster. So it's not just using cores of a machine at that point. It's actually using nodes on a cluster to do your calculations and do your compute.
Okay, so if I walked into like a big bank, Citibank, credit card fraud department, machine learning, data science, that's how they'd be doing it, I guess, right?
Yeah. Joe, do you want to add some flavor to this? I know you have a lot of experience with this.
Yeah. Let me see. You're walking into a big bank finance. Is this the use case you're working on, or?
I'm working on credit card fraud detection.
Oh yeah.
And I have like hundreds of millions of rows.
Okay, so that's not that many rows, thankfully. Like, I think it just depends on what the security requirements are of your client or who's providing the data, right? So, I mean, typically they would have, if it's a financial institution, I wouldn't be surprised if they have just more kind of on-prem type stuff. But yeah, I definitely get out of the habit of running that size of data on your laptop, for example. Or you mentioned 128 cores, that indicates it's probably a server of some sort.
Yeah, there's servers and all the cores are unused when I create these features.
Yeah, I would use something like Dask or Spark. run the data, just distribute the data out. So I mean, you could probably do stuff like chunking, I guess, in pandas, but pandas isn't really that optimized for like really big data.
Okay, so I should look at Dask or PySpark, right?
Correct.
Okay.
Yeah, I'm more of a Spark fan, but
okay. All right. Thank you. Thanks.
Of course.
Yep. All right. So our next step here is in data preparation. So what we're trying to get to is essentially in machine learning, there's this formula where we have something we're predicting, we have some function that we're applying to a matrix or a table of X and Y value, like of the data that you go in. So if it was a very simple, you know, for example, our example is like, if you take Y equals M times X plus B, this is a model that is taking, you know, this is a functional form that is taking values of X and converting it to Y. And something that we've seen, probably sometime in our education. And what machine learning really why it takes off and is efficient is because it uses linear algebra. So instead of having one X, it will use a whole matrix of X values, a whole matrix of Y values. And then it'll use, so one of the key aspects of most machine learning is that it uses linear algebra to do it, these transformations instead of doing for loops. Eventually it does a for loop, but there's very optimized for loops if you have your data structured in a large matrix instead of trying to loop over individual values. And the other key aspect of machine learning is using the parameters that we talk about, hyperparameters, are really like M and B. And these parameters get changed until X equals the values of Y that we care about. So there's the other aspect is essentially a formulation of how to adjust M and B in a way that gets you closer and closer to the right Y value. But developing our X is really the next, like the main result of data preparation. Sometimes this is called feature engineering. And in feature engineering and data preparation, we want to look at our different data values. I have, again, a function here that is taking my input data. So if we look at our input data, it was all these different columns. And now my output data is very simply just my input value is the timestamp. So this is my only feature, is just the time and the prediction. Now the model I'm using actually does create some other features, but it's going to be hard to go into that right, I think, in this talk, in how I have it in the current state it's at. But the important thing I think to understand is during data preparation, you're doing different manipulations of the data to help with your ultimate forecasting of, if I give it some set of data, can it predict the future? So this shows the basic view. I'll give an actual, yeah, we have in the data prep, this is my create features function. And so all the different things, like the different things I could do of filtering, scaling, sampling, transformations, smoothing. We could actually do, let's do some live coding. So if I want to do, I don't care about my weekly features. I don't care about daily features. I just care about weekly features. And so I'm going to actually do a rolling mean. And so what's happening is for every 7 days, it's calculating the mean for the view count. So now I've adjusted what my features are. I'm going to drop any missing values. So this will probably remove the beginning of my array. Again, I use this functionality that I get to save here. Over here, I can rerun it. And now you can see, I'm going to plot above and below kind of the differences between those two. And if I wanted to actually, like, I could do a view where I show the differences. And again, with the idea of creating, if you create this as a pipeline, doing these sorts of plots and then putting them somewhere so you could view them later, that allows you to automate this in a way that's not dependent on the notebook. The notebook is just your interactive environment for developing. Your scripts are really where you do the code.
So can I ask a question about that?
Yep.
So like when you deploy this to production, your create features function, would you like do a data frame dot write to file somewhere for each week that you ingest data, or how often do you create those files to like manually check on?
Yeah, it depends on the project, the problem you're trying to solve, right? So weekly, daily, maybe it's even a stream where it's updated consistently, like your feature store. So like some things will just have a function, and every time they get new data in, we'll run this function and store the features for you. So kind of how often it happens is dependent on the problem you're solving. But then you're definitely right. You take those features and store them somewhere. So in this case, I'm just storing them to my file system. So you can see under data, I have features.csv. And that's a step here where I actually store the features, and then I could read them back out. So here's the rolling mean now. You can see that updated when I ran my save store features.
When you do that though, does it overwrite the previous file? Would you want to keep like a history of that, or?
Yeah, you would. I think it depends, again, on a little bit how you structure it. You do want to keep a history of the training data you use, the forecast it came out with. If your data is too large, maybe you can't do that and you just have to store like indexes. So one way is like, say these features are rows in a table on a Postgres database or some sort of database. Especially because these values are historic, I'm going to pull these once and then never need to pull them again. And so the data engineer on my team, or the data engineer that I become when I want to do that, is it's going to be pulling data and adding it to a table. And then when I do my training as a data scientist, as a machine learning engineer, I will just specify, hey, this is when the training data was pulled from. So I might give my start and end time and not need to do any sort of reprocessing of the features. I could just pull those features out. All right, so now I'm creating a model. So in this case, I'm using Facebook Profit. It has some set of hyperparameters. So just like that mx plus b, where m and b were my hyperparameters, this has, I'm going to make it its own dictionary of parameters. Hyperparameters, this is going to unpack. I can't spell anymore. All right. So this creates my model for me. And if we want to go look at that code, it's a very light wrapper around Facebook's Profit. But one of the things I did here is I gave it a name. And one of the things I find I do a lot is I create some sort of mapping between different models and different parameters of that model and a name. So I might have like another model here that's going to be Facebook Profit yearly or something like that. And then I can, or I might have another model that was my decision tree. And it's going to use some decision tree with a different set of hyperparameters. And so this model name becomes kind of a key that I use throughout to say, hey, this is the model, this is the specific model that the kind of model I'm training. And then also relevant is kind of the parameters that I'm using. And there's different ways. This is not a totally solved problem, and there's lots of tools that do different ways to kind of structure this. But at its core, you have some model code that encapsulates the function, and then you have the parameters for that. So here I have, it's creating a model. If I want to just print that out, this is the signature for the profit model.
And question with the model, if I could.
Yep.
Is the FB profit model like a pre-trained deep learning thing where you just do transfer learning, or is it more like a XGBoost single decision tree thing?
It is not pre-trained. It is not a decision tree. So it's mainly a linear solver. So it's doing a linear combination of functions, which is not the same way that XGBoost would behave. Like it
uses stand behind the background. So it's like it's more of like a Bayesian statistical approach to forecasting. So it's not a traditional machine learning model in that sense, where you're giving like training data and test data. It doesn't really work that way. You just give it an input data and it gives you an output. So it's different-ish.
Yeah. So that's another choice would be like ARIMA, which is a traditional model that's used. I think I didn't mention it. So Facebook's Profit, ARIMA, these are different forecasting models that are traditionally used, but other models such as a decision tree like XGBoost can be used to do forecasting as well.
Although in that case, you only get maybe it's a typical regression output.
Yeah.
So you don't necessarily get the time series component that you would with something like the Profit or an ARIMA or an exponential smoothing model.
So Joe mentioned a little bit about training and testing. I still recommend, like, in doing the train and test set just has some extra constraints on it. So in a traditional like decision tree, you don't necessarily have a temporal component where your values going into your model are going to, you can usually treat each point independently, but in this, we split up the data, and this is called, there's kind of two ways to do this. You can either do a sliding window, which is what this is, moving forward, or an expanding window, where the start time never changes. But this is taking our data and dividing it into a section that I would put into train, and then a section that I'd put into test. And what I'm going to do with this is essentially say, like, if I gave it this input data, could it predict this output data, and how well? And then you would run this over different time ranges, and this helps give you some confidence that this model is going to work in lots of different scenarios for your particular set of hyperparameters for your particular data set. So here I'm defining windows, which is essentially just the start and end time. So if I show, windows is the start and end time for my training set and the start and end time for my test set. Here is actually plotted with the data. So one window, second window, third window, fourth window, fifth window. And then what I'm going to do here is actually do a training where I just pick one of these windows. So this very first model, this very first set of data, I give the model this amount of data, the blue, and then I predict this orange piece here. And so in my train model, this function, I don't want that anymore, is a pretty simple, take the model, take the features and my window, split my features into my training set and my test set, do a model dot fit. So this is an API that often gets used where dot fit, you give it the data that you want to put in and train on. And then I'm doing a prediction where I predict on my training data, I predict on my test data, and then I keep around my training data, my test data. And so Drew, this is something that you would store as like I trained, and it would store all of this information either, there's different, especially different tools that help you store data. Will store this information so that you can actually recreate how it trained and see if there's any anomalies in its training, kind of what data was it being given? What did it tell me that was the result?
And would you want to store like your loss function with that as well? Like how accurate it was?
Mm-hmm.
Okay.
Yeah. So something I haven't added in here was actually like metrics. And so a little bit because but if there's a import sklearn is one of the, is a machine learning library for Python, metrics, and then it has some functions that help with doing metrics. If I want to know what my accuracy, I could use that. There's...
They have a mean squared error or something?
They do. They just have an accuracy one.
Oh.
Oh, can't remember what the... Usually my editor helps me with this. Accuracy score. Haha. So accuracy score is going to take the true value, so my test, and it's going to take my prediction. So if this is my test predict, or we'll call this predict test. I'm just going to put this up here. And then under predict test, it's a table, and one of the table values is y hat, which is the final predict value. And so this gives me my accuracy. If I come back over here and do my training, this is going to capture all of my training results. And if I do metrics, accuracy, that should print out the score of that. And so you can put other metrics in here. This is kind of the data aspect. And what we're talking about really when we're talking about accuracy and metrics is evaluating how well the model did. And so in evaluation, I have this simple function that just, right now it just passes through. But if I wanted to do any other transforms before evaluating, I could. So this, I could put metrics in there. Continuous is not supported.
I think it's because the accuracy measures only take it creates it's like a confusion matrix accuracy. That's right.
So is it a type problem? Hey.
No, well, it is, yeah, because accuracy is typically something you'd use in a classification, like true and false values.
Oh, right.
right? So, but when you're dealing like times, you typically want to use a metric like mean average percent error. It's like the biggest one that you'd use. So MAPE or MAPE's like the standard you'd use for that. I don't know if sklearn has that though. So
I think it does. I think I did like a Kaggle micro course and they use the mean and absolute.
There we go.
Percent error. Yeah. So yeah. You'd want to use that. Yeah.
So one little note on the development on how I'm doing this. Joe is entirely right. He was ahead of me on like being able to like see the problem, but you can actually use a debugger, and this will drop you back into where the code crashed and allow you to execute new code. And so I find this really useful in this kind of environment to be able to go in. I could do that exploration. I could try rerunning the function. I could see what actually worked. And then once I get what works, I can put that back over into my code here. All right. I might have had a problem saving. Nope. So this is just going to give me the same error again. Oh no, that worked. It must have just not reloaded my code yet. Bugger. I was
have a trailing comma after the last values. I don't know if that would do anything.
This one?
No, the predict test y hat has a trailing. I don't think that would do anything, but that's probably the only difference I saw.
Right here?
Yeah.
Yeah, the trailing commas are not parsed, not problematic in Python. I think what happened is this was a little bit misleading. So it just hadn't updated my code yet, hadn't re-imported. And PDB pulled up the actual code file, and the code file had then been updated. So the code that it was executing and the code that it was debugging against were different. You can occasionally get into that step if you're doing things like that. So this is not accuracy anymore. All right, I'm going to talk a little bit. So while this is running and still training, talk a little bit about I have a visualization. So some other evaluations of like, did this do well? Well, one of them is just like plotting it. Did it even do what I wanted? And here, the limits, timestamp, it's a little bit hard to see. So I'm going to go 2017, 04. I'm going to zoom in a little bit, 01. So I'm going to change the axes of my plot. And 08. And so this zooms in and says like, the purple in the back is how my model did. The blue is the input data and the orange is the output data. So it's doing pretty well. It actually does a thing. It predicts values into the future. It has a 2.8 mean absolute error. And then
can you briefly explain what the bands are around the results in that graph?
Yeah, they are a lower and upper bound. I can't remember what the default is for profit, whether it's a deviation or a confidence interval. Do you know, Joe, offhand, or does anybody know offhand?
I think it was a confidence interval. Yeah. Can't remember what it defaults to, if it's 95 or 97.5, but either way, whatever.
Yeah. So it might be something like you'd interpret it as, if it's a confidence interval, you'd say 80% of the data, there's an 80% chance that your value lives within there. And so you can see all of these data points follow that. There's a data point here and a data point here of real data that fell outside of our confidence interval. And this kind of comes back to my beginning point. The future is hard to predict. And as well as you can do a prediction, the future is going to throw you curveballs. And the best, if you're doing somewhat good, it depends on your problem set, right? Your problem of how close you have to hit that. But yeah, you're probably never going to get it right on.
And that accuracy, just to clarify, that 2.8 is the margin of error for views per day?
Well, it's the rolling 7-day window average, right? Because
Okay.
I adjusted what I was actually predicting to a rolling 7-day average. And we see here, another thing I always plot whenever I've done some sort of model fit, and I have this, is plot the residuals. So the difference between my input data and my model. And so this shows you kind of how well, what kind of random noise is it doing? Is it overfitting? Is it underfitting? Is it missing a trend? Sometimes you'll see it going one direction or another direction. And that's going to get taken out in this particular model because it accounts for trends, but sometimes you'll see things like that, and that can lead you and help debug what things you need to change either about the features you're giving it or the model you're choosing.
I have a quick question before I had to go. So for the Jupyter, I'm seeing that it's kind of like using Python REPL, right? Refactor point, right? Seeing that Jupyter is more flexibility and useful than REPL, if we're using it so we can see how it's game played. Now, does that mean you can take these input code and make a script out of it, like automatically, or do you have to manually copy and paste one over?
No, you can create a script. So there is Xbook Notebook download. There's a way to export it as a script. Ooh, that might actually be under Save Notebook as. Nah. There's a way to just get the Python script out. The thing about developing in a notebook versus developing it just as a script, the notebook abstracts execution environment. So if I do A equals 4, and then I go A, how do I, plus 10 to be 14, and then I go A equals 10, and then I go back and execute this. So these numbers actually dictate how it was executed. And when you get in deep on notebooks, people often end up doing various things like this where you're executing out of order. I might go back up and modify some other variable or change things. The way around this is just to rerun everything, but it's still not a great environment for actually making scripts. There's not really good ways to import until you export it as a module. It puts everything, when you're creating scripts, the best way is usually to do this if name equal main in a script and nest everything. So if my script was A equals 4, A plus 10, right? Then I can import the module, because when Python imports, it actually runs all of this code. So if we actually put something there as a module, I'm wondering, hey, there it is. It ran this code. And so if you just export this as a script and then try to import a function from this, it'll execute everything, which is not a great environment, right? Like, it's not great. You don't want it to do that. So just taking a notebook and exporting it is not a great way to make it as a script. The notebook as a REPL, like, it is kind of the same thing as going into Python, typing it out like this. But what it gives you is essentially a document to to organize, like I organize my thoughts into a notebook. I have the graph. I could say like for a particular visualization, I could say figure, you know, this is fitting the data well, but misses some of the peaks. Should go back and make more fine grain. So now let's look 6 months into the future. I come back to this project, I open up this notebook, and now I have all of this documentation about what my thought process was around experimentation. I have all of the functions, I have, you know, text, I have figures and the text that goes along with it. It's essentially a nice way to make exploration, like the scientific documentation of it, instead of just having it in a REPL over here where it all goes away at the end.
I can see how useful that can be. For example, whenever you write code and then like a year later you look back your code and you're like, I have no idea why or what this way or what this variable means. So I can see the benefit of having the notebook and associated with the code, so that we're using, oh, it's because I was trying to do this or that, and then we understand the code again. So that's pretty cool.
Thanks. Yeah, so we are, I guess, am I running 20 minutes over now? Is that?
You're fine by my book.
You just muted yourself, Dylan.
Dylan, you're muted.
Yeah.
I can unmute people. That's kind of fun. I just unmuted him for it.
Oh, it's like a superpower.
I know, it's like a superpower. I can hear anything you're doing. But
that's not creepy at all, Faris. All right, so
Zoom.
All right, so yeah, I think let me go through the last little bits that I want to make. We can do any closing questions on this, and that'll be the close of my presentation. So the last two steps that I kind of had here, parameter tuning and prediction. So in parameter tuning, I might take different models where I have these different parameters. So there's a yearly seasonality. Maybe I'll turn that off and actually turn the daily seasonality on. And then I want to retrain the model. Now that I have it in a function, I can actually get something that will automatically retrain those, or that'll go through and retrain those, and could output these different plots. And like what I was mentioning about saving these training results, you could also, and if you saved those out to a file, you will also save these plots out to a file. And now this is actually around, this is an open area of research. This is kind of what the senior ML engineer that my company is hiring is trying to solve, is there's tools that will help you rerun these. So once you have a function, that function can be run with different parameters to train, to give you the outputs. And then you could actually create a web interface where instead of writing code, you then put in all the parameters. It runs a bunch of different options in parallel or on different machines or however it wants to execute them efficiently, and then can give you back the results. And you could put this into a pipeline. So when I push new changes to the code, it could rerun a set of steps because it could rerun the functions now as a script. And this is kind of the future, being able to design your code in a way that you can change the parameters to it and see the results and track the results is really kind of the future of where machine learning is going. And there's lots of tools such as, I mentioned here, Kubeflow, MLrun. OpenFOSS is not quite a machine learning platform, but it's a useful tool. And these tools allow you to take your functions and run them in a clustered environment on different machines. Now that we have this Docker image that's portable, those things can be moved out to the cloud and now run in in parallel can be run to do comparisons and to do do parameter exploration to find just the right parameters to tweak them. And so this is really bridging that gap between, hey, I got this working in a notebook, and hey, this can actually work in production. This can actually, I could test out lots of different parameters at scale and not have to just rely on my notebook, on my computer to run these explorations. So pulling back up, oh, that's not it. My slides. This is me just talking about kind of what I just mentioned. I have a few resources that went into making this talk. One that I have found valuable and just like reviewing for teaching this, as well as reviewing different pieces about time series forecasting was this person's book, but also the blog that supports it. So Machine Learning Mastery / blog. A lot of the things from the book are actually just blog posts here. And so there you can see things like random forest for time series forecasting. It's a pretty short little blog article that just gives you a nugget to learn and try out. And that was one of the resources, as well as a few others that I list here. And before I take any more questions, I just want to thank everybody for their time and listening to me go through this exploration of time series forecasting. So thanks. Give a nod or put a little wave so I know that.
Dylan, anytime you give a talk, like, I always learn so much. So don't even like self-deprecate right now. This is a phenomenal talk. So thank you.
Thanks.
Any questions for Dylan? This is great. I totally want to do this with, like, I have a temperature data set that is has anybody played with Home Assistant? I'm going to paste a link. It's kind of right down Dylan's alley because it has to do with like home automation, but it's an open source way to do home automation that integrates with APIs of like stuff that you already own, but it can run on a little Raspberry Pi. I'll link it. It's a Python project. It's really cool. So if you're interested in getting your own data sets and then possibly doing predictive analysis on them.
Dylan, with this Facebook profit, you were talking about matrix multiplication for like linear algebra.
Yep.
Does that run faster if you've got like an NVIDIA CUDA, or do you have to like add special code to make it run faster with that? Because I know like image stuff would.
Yeah, I don't think Profit will leverage. It uses Stan as a backend for it. And Stan is really going to define, like, it does a transform where it takes that input data I gave you and turns it into its matrix that's going to multiply with all of its different, it adds some features in it actually. But then the engine, the Stan backend, is really what takes that matrix and does the computation. And the default, I think, will just use a CPU, but I do believe, I don't know if they have a backend that will use like a GPU, like NVIDIA. But for other machine learning models, that level of how does this execute, whether CPU or hardware, tends to get put into that framework. So whether it's Facebook Profit or TensorFlow or scikit-learn, it can actually leverage those resources.
I found Profit did like 40 million forecasts or something like that, and it was just on a basic server. The thing with time series forecasting is it's different than machine learning in a lot of ways, but the way it computes is different because you're simply passing time series data in to get a forecast. It's fundamentally different than how you would do machine learning, which is you have a training set that you're trying to build a model upon, right? So it's, to me, they're almost two classes of ways of dealing with data. So.
Yeah, it's a fair estimate because yeah, what you're doing is you're passing in all these X points and you have some model that's already fit, like that's already there, and then you're tweaking it. So like you think of just, if you look up linear regression and you treat linear regression as a time series, let's see. Let's pick out, let's just look at an image here. So linear regression really is that MX plus B type of model. And then if you imagined all of these data points were connected as a time series, right? And you put in the first 80 data points as the first part of your time series, and then the prediction on the output as the second part of your time series. This is really what the time series forecasting for things like Facebook Profit or ARIMA is doing, is it's taking just a simple functional linear, like a simple form of the function, and then finding the best fit for these data points, and then doing a prediction for multiple data points in the future. Whereas machine learning will really treat each data point independently. And if you wanted to treat it as multiples, you actually have to put in the different multiples forward and back and predict out one. You might predict out just 1 point into the future, and you'd actually train multiple models that would predict, you know, like do 1 timestamp, 2 timestamps, 3 timestamps. And so in that case, you might even have an ensemble of maybe 10 models to predict 10 future timestamps. And each of those models would get trained, and then that ensemble is essentially your forecasting model, but it consists of many different models.
When you talk to people who kind of hardcore time series forecasters, it's funny when I talk to people who have been in the space, like old school people, like people like kind of a lot of these algorithms, but you talk to them about like the newer approaches, and they all prefer actually, I think, the basic stats models. Like ARIMA is still pretty popular, exponential smoothing's pretty popular as well, because it just works really well. And it's like, you don't need a lot, because all it does is you're correlating lags and time periods. And it's really, really simple. More recent deep learning advances like DVAR, for example, you're not going to get much more out of your forecasting. We're just using the basic models that have been around forever, and like these kind of books here, right? These books are around before, like this one was written in, let's see, 2009. I think this is from the 90s or something. Yeah. But the whole point is like you got to understand too, forecasting is an interesting beast where you're always inherently going to be wrong, no matter how hard you try. So like, how much horsepower do you want to throw at something that's 100% of the time going to be wrong?
Yeah.
Right. Like, how much more accuracy are you trying to get out of it? It's always been sort of the paradox of forecasting, because it's wrong. So like, how wrong do you want to be, and how right do you have to be to, you know, until your forecast blows up. Sorry, my kids are wrestling in the background, by the way. So.
No, and you can see that really here. Like, this model is like, if you just put a line to this, right? Say right here, this is mostly just a line. And that's kind of like with all of this extra functionality, there'd be really no way to predict it going up or going down. Like, you're always going to be wrong. And if you can get, like, if you're capturing the pieces and doing a good enough job going forward, then that's probably going to be good enough. All right, so that I think that concludes my presentation, and we could do our raffle and close up here.
Awesome. Yeah, I'm looking through the group chats. A lot more usage of the Zoom chat. I'm loving it. Yeah, everybody loves the presentation. Let's see what else. Boom, boom.
Oh, yeah.
Oh, Home Assistant is not the name of Dylan's company. That was just a link I put in. Dylan's company is Verdigris. Verdigris.
Yeah, I learned this after, but verdigris is the green that forms on copper. The name of that is actually verdigris, that stuff.
So like on the top of Canadian Parliament or the Statue of Liberty?
You guys like oxidize stuff.
Yep, it's the oxidized stuff.
Interesting. Sweet. I'm gonna share my desktop here and let's find our Slack. I'm gonna make sure I'm not on my work Slack because, you know, that's a thing. So has everybody had
don't want it recorded?
I know, right? Has everybody had a chance to join the Meetup Slack? And also you need to join the Meetup 2020 1104 channel. Now, the reason for this is what I'm going to do is I'm just going to say /who. Wow, wait, what? What? They got rid of, okay, sorry, Slack changed something. Is this still a thing? Okay, cool. So clearly there's more people who still need to join this Meetup channel. There we go. Hi, Marcus. And then we're going to write some Python code. Oh, and I just realized I was actually using VS Code for like work. So I'm going to fix this real quick. Okay, can we see this okay? All right. This was how we did the raffle back in October. So I'm just going to duplicate this, make a new file. Come on, there we go. And this is pair programming, so this counts, right? Can everybody still hear me okay? I feel like I just lost sound. Yeah. Oh, okay, cool.
+1 on your code.
Sweet. Awesome. Okay, so last chance. This is when I'm going to type in who. And then I just copy this. Oop. Wow. Considering I'm giving away 2 raffle prizes, this is actually really nice odds. So this code looks good to people. Can I get a thumbs up for peer approval? Yeah, I like it. Okay, so this is what we're giving away. We're going to give away 2 PyPortals this month. If you don't know, PyPortal is a Circuit Python-based little single board computer. As you can see, you can put a speaker, you can put a battery. On the back, there's a lot of pinouts. I'm trying to like look on this part. And then you can put I2C on here, which means that if you wanted, you could put analog input in here, which is great if you're measuring something like temperature or any other real-time data. You see what I did there? On the front, we got a little display, but we also have these 4 little buttons and 2 over here. It's almost like a Game Boy, have some buttons on the top. And then we have all, these are 5 RGB lights. And all of this is editable with Python. These are pretty great. Micro USB, you basically will copy and paste a code.py file. If you win this, yeah, that's great. I'll send one of these to you via USPS. What was the other note? Oh, I will add, now's a great, or these are great for education. So I would encourage, if you know somebody's getting into Python and you win one of these and you're not really into it, still, I'll ship it to you as long as you give it to that person. Like, feel free to, and I've had a few people tell me, hey, I don't want to get a prize. Get the prize and give it to somebody else who you think can actually use it. So yeah, that's what I got. Oh, I'm just looking on here. Oh yeah. There's a light sensor right here, A7. I forgot about that. This has an accelerometer and a light sensor. There's a lot of inputs and outputs you could put on this. This particular thing, the only thing this board does not have is internet connectivity, but it does have a way to serialize like outputs back down the line. So you could do some cleverness, like add this to like a Raspberry Pi, and then it could be kind of your controller board for whatever. Or people have actually made like little platformer games that it's kind of incredible if you think about it. Like in the 80s, something like this would be, you know, a big box typewriter thing. Anyway, enough of that. Let's actually run the raffle, shall we? We're going to give away 2 of these, so I'll just hit the run button twice. And drum roll. Come on, buddy, you can do it. Random is not defined. Ah, who peer reviewed my code? Jeez. There we go. Sahulia Noor, you're the winner. Are you on the Zoom right now?
I am.
Oh, hi.
Yeah.
Congratulations. So yeah, just send me a Slack message with your address and I will ship one of these to you tomorrow. And then our next winner, yeah, congrats. Our next winner is Joe. Joe, you won a Pi badge.
Oh, great.
Well, do you know somebody you want to give it to, or should I run this one more time?
You know what? I'll take this one because my kids, I'm teaching them. I finally have a use for all the Raspberry Pis I've collected over the years. So. Oh, pro tip. This is a whole other thing, but pro tip, because I've collected too many Raspberry Pis over the years. NetBoot is your friend with those things, but that's a whole other topic that I'll get into later. But anyway, that's the raffle. Cool.
Yeah. Let's see, calendar, and then what? 2020? No, Cal 2020. That's what I wanted. So our next meetup will be the 2nd of December, and yeah, thank you all. Oh yeah, it's already booked. What was the topic?
Monitoring machine learning models. My friend Danny, who's a brilliant data scientist, he's given this talk on, yeah, I think real-time monitoring of machine learning models too. So that's gonna be really cool. Using all the cool buzzwords, Kafka, streams, ML, monitoring.
Kubernetes?
Yeah.
Just kidding. Yeah.
I think it might actually, yeah. So yeah, stay tuned. You'll get your, whoever said they had the buzzword bingo card, yeah, you'll fill it in like 5 seconds. So it'll be great. So.
And in the more in-person versions of our meetups, we tend to walk over to a pub or have like an after meetup session to network. So I'm going to end the recording right here. Boom. So thank you all internet people for watching.